Innovations in the bond market. There have been many innovations, and probably overlook a few of them here. The Many of them good, many of them not so good. Um, First example is what are called inverse floaters. We talked about floating rate securities. Floating rate securities are just a variable rate security that interest rates go up the rates on them go up as interest rates go up and go down if they fall. Inverse floaters are the opposite. They move in the opposite direction of interest rates. Common way to issue inverse floaters is in conjunction with floating rate securities, and this allows the issuer to achieve a fixed rate. The thinking in this case is that the issuer can, by creating this structure, they end up with a lower interest rate. I'm a little bit skeptical as far as that the case myself, but so coupon falls when interest rates rise. Asset-backed bonds. We all know about asset-backed bonds in the case of mortgages. Income from specified assets used to service debt. Mortgages, very popular. Asset bonds are vehicle loans are very popular. Credit card loans, student loans are they're student loan backed bonds as well, and many other types of asset backed bonds as well. Payment in kind bonds. The issuer can pay interest in cash or additional bonds. These are very high risk bonds. Catastrophe bonds, another form of high risk bonds. Higher coupon rates to investors for taking on risk. So if the catastrophe bonds wouldn't pay, if the issuer wouldn't be obligated to pay if the project failed for some reason. Index bonds. Payments are tied to the general price of some index or a particular commodity. Example of index bonds are what are called TIPS, Treasury Inflation Protected Securities. The par value of bond increases with the consumer price index. This is done on an annual basis, and the par value of the bond will go up based on the increase in the CPI. So the principal grows. The bond also has an interest rate that was set when the bond was issued, and it pays interest using that increasing principal amount. We'll see an example on the next page. So the nominal return is this is just a different variation of the rate of return formula we've seen before. It's interest plus price appreciation divided by the initial price. The real return is 1 plus the nominal return divided by 1 plus the inflation rate minus 1. So we've got a 4-year table here, 10-1, showing TIPS example. This is a 3-year example. So we have the first column's time, then we have inflation for the past year, and the par value. So we started out with a par value of $1,000. The par value grows by 20% the first year, 2%. The 2% here, the 3% the next year, and 1% the following year. So then the coupon is the interest rate multiplied by the par value. So you can see the coupon payment grows with the par value of the bond. So bond pricing. The bond value is the present value of all the future coupon payments, and the present value of the par value. So the formula, it's the sum of the present value of all the coupon payments and the present value of the par value. We did an example previously showing how to calculate this in one of the previous lectures. You can refer back to that. I'll work some other examples also for the problems with regard to this chapter. T is the maturity date. R is the discount rate. So just like before. So a little more involved the formula, but coupon multiplied by 1 divided by R multiplied by 1 minus 1 divided by 1 plus R to the T. And then par value divided by, in this case they multiply it by 1, but it's just par value divided by 1 plus the discount rate to the number of periods. So 30-year bonds, and for most cases, 30-year bond is going to be a semi-annual payment. So this R is going to be divided by 2, and T is going to be 30 times 2 in that example. So we can also do it by calculating factors and so forth. There's also formulas in Excel that will calculate bond prices. The no bond price formula uses or calculates accrued interest. So one thing to note, your calculator will calculate the accrued interest, and you can you need to use that when calculating prices. You can also calculate it in Excel if you choose to. Example here, we've got a bond pricing for bond A. We've got a 4-year maturity, 5% coupon rate, an 8% discount rate, 30-year bond, and same coupon rate, same discount rate. So bond A, we're assuming that it's trading on an interest payment date. So bond A, simply we'd have 50 multiplied by 1 minus 1.08 to the minus fourth. All right. I don't really like the way they set their formula up here. It's the same as the other formula, but they use a negative exponent instead of, which is the same thing as 1 divided by 1.08. Then R is the coupon rate. So they're calculating this bond as if it's a 4-year bond on annual pay. So the left-hand side accounts for the coupon payments. The right-hand side is the present value of the maturity value or par value of the bond. So the components of that, $165.61 is the present value of those coupons, and $735.03 is the present value of the maturity value of the bond. So the value of the bond's $900.64. Bond B, being longer maturity, we've got more coupons. So we've got this down here. This is the present value of the coupon payments. So we have 30 coupon payments instead of 4 at $50. So that the present value of those 30 coupon payments is $562.89. And then the present value of the maturity value or par value of that bond, you're not going to receive that bond for 30 years, so it's much, much less. So the face value or the price of that bond is much less as well, because of the longer maturity and the longer period to discount. So we have present value of the coupons, 165 versus 562. Present value of the par value, 735 versus 99.38.